Just to confirm, everyone can see the screen?
Yes, we can see.
Okay, perfect. Thank you for the intro. This is me, a picture of me without a beard. So just to give you a bit more context about my background and biography, I did study my MSc at QMUL University, as Sukhpal just mentioned. And during that time, I had the pleasure to do a research project with Airbus on secure data exchange, specifically allowing secure data exchange of classified information in a cloud environment, in fact, of an isolated cloud environment. And I did this project with Steve Ulick. And I have a bachelor's of business administration. And during these times, I was able to work at Airbus as well and at MBDA missile systems. And on top of that, I was able, whenever I had free, I continued studying, and I studied also in China at Peking University. And I did grow up international, so I did live in Turkey, UK, and Spain. So concerning MHIT, the company I work for at the moment, the industries we are present in is in public healthcare. We also develop blockchain applications there and consult, I would say, renowned customers in the aerospace and defense industry. We're an approved Airbus supplier. We have some consulting projects there as well, supply chain and automotive. In the past, we've worked with Volkswagen Group. And in technology and software, our colleague Zoe is extremely experienced in that when it comes to Web3. We work with the Web3 Foundation and also some startups in the Polkadot ecosystem concerning cybersecurity and blockchain projects. Basically, we have services where we do consult additional companies and solutions where we sell and build customized products for cybersecurity or blockchain applications, and a school where we provide cybersecurity awareness trainings, and also additional aspects there where people come to us and we educate them. Usually it's all on the B2B landscape. So today, the rationale for this presentation is actually where I will talk about a specific client which we have in the cloud computing sphere, and they are solving a very relevant problem of confidential cloud computing and verifying transactions in a confidential manner. They're tackling, I would say, a very unique pain point. And I don't know how far you're already in the course, but I will just briefly go over encryption to understand this, because this is a relevant aspect where the solution of our client builds onto its Fala Network, and then go through the basics, and at the end also the infrastructure and how the network works on a distributed cloud basis. So the core concepts in data encryption, we have plain text that is encrypted into ciphertext. This is how we commonly transfer information throughout the internet, through servers, in a confidential manner, because it's nearly impossible to read the ciphertext during the transmission phase. And whenever it arrives the recipient, it is decrypted. That is the common way, or a simplified high level, how encryption works. And there are two types of encryption. So one is symmetric encryption. Exactly the way I just described. It is fast and efficient because you only have one key pair and you don't need to worry about exchanging keys, as if you would have to do it with asymmetric encryption. So in asymmetric encryption, you do have two different key pairs, a private key and a public key. And here it is referred to the public key, and the secret key is referred to as the private key. And it works with the same principles, but that you have to exchange the key pairs, which means with your private key, you do go ahead and encrypt the data. And then, the data is encrypted with your public key, obviously, and then you send it out and you're able to decrypt it then with the other key pair. It is pretty good for communication, but it can also be slow and expensive because you do go ahead and have to exchange the key pairs. So if you go ahead and invert this, what happens then if you invert this? So you go ahead and try to decrypt it with your secret key. What happens then? There's a question to the students. So first I just talked about encryption and what happens if I go ahead and like sending the messages, but if I invert this mechanism, what happens if I decrypt it first with the secret key? No one wants to answer that? So I do go ahead and sign it if I invert this mechanism of symmetric encryption. So this is how I can sign messages. So I do sign it with my secret key, the also so-called private key that generates a signature, and then it can again be verified with the public key as a plain text. This is how you verify the integrity of files in common mechanisms. This can also be used on the blockchain, for instance. When you have a transaction, it is signed with your secret key and then uploaded to the blockchain. And then on the blockchain, this can be verified by reading whatever is on the blockchain, and it can be encrypted with the public key, which is called the mechanism where you verify the signature. This is one common use case. So there is also an additional concept of hashing. You probably all heard about hashing functions. So the SHA-256 is a very common checksum, which is used, for instance, to hash files to double check the integrity of a file. So you go ahead, you have a file and you create a hash of it. And whenever you change something of the file, the hash changes. So that's how you can verify something has changed. If it is, or if the data is still within its compliant by all means. And what is usually done is passwords. They are usually hashed or stored on servers in a hashed way, so that it is very complex to derive them in terms of when data breaches happen. You would only get, as a hacker, access to a database, and you would find hashed values, which still wouldn't necessarily always give you the power to actually derive the password from that. And on top of that, there are also mechanisms where they are salted, so which makes it even more complicated to derive a password from a hash. And it is almost impossible to inverse a hash of a function. So that's why hashes are used for data integrity purposes. So semantic encryption uses the same key for encryption as a conclusion, and asymmetric encryption requires a key pair, a public key and a secret key. And you encrypt it with your public key and you decrypt it with your secret key. And the secret key obviously only remains in this circumstance with you, and the public key is usually shared. So that's how you do you verify signatures and are also able to encrypted messages over and decrypt it yourself. And if you invert it, obviously you sign it with the secret key and you verify it with your public key, which builds the base of identity. And the hash is used to ensure integrity of files and data. And it's impossible to restore the data given the hash value. So if we take this knowledge now and go ahead and take a look at how smart contracts are executed. So this is now also referred to as a blockchain, but a unique feature that blockchains can do. Current blockchain environments, and most of them, specifically Ethereum, you have a worker, so-called miner, which is nothing else than a server that executes the transaction. It updates the contract storage during the block production. And then other workers re-execute the same transaction, and that's how they verify the contract storage. That's how they verify the integrity of that transaction. So the limitations which arise from there are that all the data is processed remains public, and computing power is also not that scalable. That's why the gas fees, so if you're in the crypto space, maybe, that's why they tremendously, especially in Ethereum, when you try to do transactions. As the network grows, it becomes more complex to scale it, and it becomes more inefficient to actually verify transactions, because you need a single worker for block production, and then all the workers conduct a duplicate execution. And this will also lead to high latency, because as it grows, you need more and more workers to duplicate this transaction to verify it. And concerning integrity and security issues, you don't know if actually a worker or a miner or server in this case is malicious. That's why you have most workers that need to verify the execution. But if you're in smaller blockchain networks, you could actually overcome this even easier if you just have an amount that is larger than the unmalicious workers. These malicious ones could manipulate actually transactions. So on top of this, all the data is public on most blockchains, and it is not privacy, and also the data is extremely sensitive. And if you would want to actually encrypt the data, where would you actually store and hide these encryption keys? So these are all the issues which have been thought of in confidential cloud computing environments. And you will also want to overcome the long wait times and also the high transaction fees, which I mentioned earlier, if you use this in a business case and develop apps on this in a cloud environment. So that's why one of our clients, for instance, there are also a lot of startups working on this as well. They thought of solving these issues by hiding the transaction keys in TEs. These are trusted execution environments, and I will talk in a bit more detailed way about this in the next slides. So they move the execution into TEs, encrypt them in all the transactions. This is actually a unique feature that most servers support today in the landscape. And there are also, another example is a secret network that works on these aspects as well in the cloud environment. So if you think about TEs, so trusted execution environments, there is a threat model in the cybersecurity landscape. If you have attackers that have physical access to the hardware and network, usually this should still be secure. And also you have the threat environment that attackers can hack the operating system. So, and on top of that, there is the requirement that you have a fully controlled blockchain. And it would also be better if the users cannot see the data, so you can use it for healthcare applications, for instance. So this was the model that was thought of, and the solution is using TEs. And in TEs, you have on the hardware level, most servers support that. So common vendors are AMD and Intel. They have in the CPU an enclave, and then on top of that, in terms of the architecture, you have the operating system. You can also have in between that a hypervisor level 1, for instance. If you have Proxmox or virtual machines, this does not really make a huge difference. You have a one-to-one communication gateway between the app and the enclave as they exchange the encryption keys, where all the data that is processed in the TE, and it's impossible to read the data that is processed. And this is actually leveraged in a larger scale in the Fala network. And also this has been audited. So successful attacks are actually highly complex and have only been successful in a research academia environment that was not really replicable in a real world example. And features are obviously, if you just take a look at this one example of the vendor Intel that offers this, you have a CPU that is verified by Intel through a remote attestation, and it also includes hardware information such as the CPU, and it supports security features, and it is also a program code with initial memory layouts. Pretty sophisticated technology. And how does this work in practice in a cloud environment? So you have servers and you have so-called workers there, which send the private key to address I for encryption, and then the key manager sends the secret key to address I to store this on the blockchain, and then the secret key is being verified by the workers, the servers in this cloud environment. And this is a technology with one of our clients we work with. They are based in China. They built this on the Polkadot parachain for cloud applications. They're called Fala Network. It's a scalable, confidential cloud computing software. And on a larger scale, in terms of the infrastructure, you would have servers that act as a gatekeeper. They request the contract key, and the workers, the other servers, they're classified as workers. They would do the contract assignments, and then as a client, where you would actually build on the apps, this would be the end user. They upload the contract, and they're able to, I would say, execute contract commands and are able to do state resource and update the state. So the limitations in there are, the limitations that are solved is that you don't have to put out your confidential data out there to use blockchain by using TEs. This is how it's being overcome. And the computing power is also scalable. So within this cloud environment, if you build cloud applications on top of it, So one single worker in Fala has 75% of the whole Ethereum network power. And you also don't need duplicated executions, which also leads to less latency, and you have near real-time query off-chain with the workers and servers in there. And also the code and all the historical texts are still, transactions are still on chain. And if one server, for instance, since it's distributed, goes offline due to a power outage, for instance, you would be able to solve the availability problem because it's distributed, then a different worker would handle this, a different server in this ecosystem. And use cases that have been worked on so far in this project are classic. You could use it for data analytics purposes, where you have confidential data that needs to be processed without putting the data on chain to verify its integrity. So in the healthcare industry, this can be used, but also to be GDPR compliant. There are also think tanks that think of leveraging this even further for joint risk control and also trust as privacy data computation and exchange. So you can also buckle this with data storage, for instance, to verify transactions and also check the integrity depending on whatever the developers make out of it, and leverage the use case. And just in a nutshell, you would the architecture or the classic architecture of one of these nodes in the network would be that you have a trusted execution environment, and then you have the substrate node, because they build on substrate node to leverage even a larger network. And then Ferry, and on top of that, you would be able to build a front end where you could execute these queries, where you in the back end have the cloud environment, depending on how it's built, to verify the transactions and double check the integrity of files. And there are also more, so as the community grows there, and also in the Web3 era, there's even a metaverse being built onto it. Game servers can be built on this, and also additional computation and storage. So that's pretty interesting in terms of what's happening there in terms of new technologies in the cloud environment. And what we basically as a company, for as MHIT offer, we do offer support for MSc projects. We're also working with other universities, which we support for research purposes. We can get them connected to these startups which leverage this kind of technology. We also have other projects in the cybersecurity scope, and support you with directly in industry partners. And if you're interested in this also as a student, feel free to reach out to us. So this was a quick and short presentation. Feel free to connect, and if you have any questions, let me know. I'm opening up the floor now for questions.
So thank you very much, David, for your wonderful talk. Thank you. It's really
You're welcome.
Yeah. So now I'm asking students. So we have many students. They can ask questions. So one by one. So I think I have seen that some hands have been raised. Students, can you please ask your questions? And maybe David, first, can you please explain them about the importance of teamwork when you're working in the industry? So we are doing the teamwork-based group project, as you have already done. So maybe first of all, you can explain them.
Yeah, teamwork is extremely important, because at the end of the day, especially if the scope of the project, which I've just showed you, no soul or single person will be able to handle this. And also in a cross-culture environment, it becomes more challenging, but you get additional ideas. And I know that the teams at Queen Mary University are cross-culture, which is a great benefit. And that's why it's important to have, usually in a real life environment, you would have a project manager which coordinates some tasks, and you would have collaboration tools such as GitHub, which we also used very well for Queen Mary projects, and which reflects actually the real working dynamic. So it's important that the team knows what they're trying to work for, what the goal is. For in your circumstance would be a good grade, and also building a portfolio actually on GitHub, which you can share with your future employers. And you would also show that you would collaborate by doing this in a team, and show that you're a team player, because it's hard. I mean, there are a lot of programmers which are not able to work in a team, and this is what employers don't look for. They look for team players. so that they can grow with this employee.
Yeah, that's really useful. So now students, can you please ask your questions or any other future opportunities? David may tell you something. So you may ask, feel free to ask. I advise please turn on your camera if possible. That would make some more interactive session. And please feel free to ask questions. So basically you are working on some existing projects, or you are just going to plan some new projects also?
So we do both. We are consultants for existing projects, but we also develop our in-house capabilities, which we sell to larger customers when it comes to cybersecurity products that verify the integrity of transactions or also secure data exchange, for instance.
Yeah, as you mentioned, like you have some like also you can support some MSc projects. So like if any MSc student want to join you, they have to join on some existing project, or they can come with a new idea as well.
So usually existing projects. Currently, the project which which I just demonstrated, the Fala Network, that's where we have strong ties. But we would also welcome their own ideas. We are happy to talk about that. So they could reach out to us either directly via LinkedIn. That is one option.
Yeah, students are just typing in the chat. Maybe you have access or not?
Yes, I can read it. So Nelam actually just had a question of what are the opportunities in blockchain? So this is hard to define. It depends on what field you're going into, because it's already a growing industry. And I would honestly, if you're a computer science student, look out for brand new startups, either in the Polkadot ecosystem or any other existing ecosystems. If you're a programmer, you would be able to have great value to add these skills. So most commonly, from my experience, it has been C++ or Rust, these kind of skills as a programmer, if that's the route you want to go to. But you could also become a technical manager then once you understand and leverage this technology. So there are actually a lot of opportunities as it's growing. It's a new field, especially in Web3. And then from Mohammed, I'm seeing another question. What is the most useful cloud computing skill to learn for getting jobs? So from my experience is get familiar with Linux, so you understand how to use it, because I do still use AWS, right?
No, this time we are using GCP, Google Cloud Platform. And
okay, so you switched to Google Cloud.
Yeah,
yeah. We use that for our project. That's also a big player, not as big as AWS, but at the end of the day, it doesn't matter as long as you have a fundamental skills of Linux and I would say Kubernetes and Docker containers. This is what you need to learn. And you do learn the basics in Sukpa's course, which helps you out there. And load balancing, that's a very hot topic as well. And if you want to show and proof case that as someone who's early in their career, do the skills, so the skill sets, the certifications which they offer. Google Cloud has them, also AWS. You can do the AWS Cloud Practitioner to start, and then you can see where you're more passionate about. Then you have more specialized certifications you can go into. And my experience is that right now a hot topic in the cloud environment is if you combine it with some cybersecurity elements. So you could do the CEH, the Certified Ethical Hacker, on top of that, just to show this skill set that you know that. And at the end of the day, everything is in a cloud environment nowadays. So if you build on this fundament, you should be good. And so Rahul had another question. He said, what projects can this lead to for MSc students? So would you mind clarifying that? You mean like what kind of projects, what I was presenting at? Is that what you meant, Rahul?
Rahul, can you please? Okay, so I think he has.
Yes, okay. And Salini has a similar question. In terms of MSc projects, if you would like to go with the Fala Network project, which I just presented, we would very much welcome if you work on use cases building on top of this technology in the cloud environment, which would mean that you would develop a proof of concept, so a prototype. And as far as I remember, that would satisfy the requirements of your MSc project as well, because you would have a prototype, something that you programmed on, which is demonstratable. And if you share this on GitHub as well, and if the professor is fine, you would definitely build an extremely valuable skill set on GitHub and a portfolio, which you could show also to additional startups in that area if that's of interest. So if you would like to talk about that, we do welcome that, especially if you already come with your thesis advisor and have that planned, and then we would take it into a direction that suits not just us, but also you. That is obviously important for us. Or also something else, if you have your own ideas there, which could build on top of that, we are always open for that. So do reach out to us. So Josh had a question. I hope I'm not mispronouncing your names, by the way, so I apologize in advance for that. As we are doing basics in the course, can you please suggest from where we can study the advanced versions of the topics you mentioned? Okay, that is a good question. So I will provide Sukhpal with some links after this meeting, if that is of interest for you, where you could get additional information about, I would say, blockchain in general. But it's just a huge topic. That's why it's not taught but blockchain for cloud environments and cloud use cases. This is what we specialize in. I'm happy to share information on what programming languages you would need and what else you would need to get, I would say, a better understanding of the industry and the community and how it works out. So I'm happy to provide that after that session if that is fine for you. So Salini has an additional question. Can you please explain me more on Fala Network? Well, this is a good question. Would you mind elaborating on that, or maybe also turning on your microphone to give a bit more specific questions? Would that be fine for you? Salini, if you have a microphone, would be nice if you could switch it on and or type it then if you don't have a microphone.
Yeah, hi David.
Hi.
Also, like, I have very little info on blockchain, so I was not able to understand like how the Fala network is being used in that application.
Okay. Yeah, that makes okay, I understand the concerns. So you don't need a deep understanding of blockchain actually if you're familiar with hashing and encryption. So basically, a blockchain system is nothing else than where you store data in form of hashes, and then other servers or participants in the network double check this transaction by going back on what has been written onto the blockchain, like a text, and says, oh, okay, this is in there, this transaction is valid. And the problem there, which arises, is if you take a look at legacy technologies like Ethereum or Bitcoin, all of the transactions that are there, the data is hashed, and this hash is actually publicly viewable by everyone, and it's not, it hasn't been encrypted before that. So if you have confidential data, such as in the healthcare industry, where you have someone's health data, you don't want to just hash that and put that onto the blockchain, because at some point, if quantum computing arises in 5 years, by that time, it will be easy to derive these hashes and get a person's personal information. So that's why Fala goes there. They tackle this issue by doing this in TEs. So they add an encryption layer and then they write it onto the blockchain. And they also have found a way to do this, that it's not being replicated. So it's faster and easier, and it's a future-proof system to do that. And this all is done by distributed cloud servers that do these transactions. That's what blockchain is actually. And you can build applications on top of this to leverage this. For instance, in the healthcare, if I go back to this example, you could do data analytics. You would be able to verify the integrity of data, to verify transactions without sharing the secrecy of the data or compromising the security and giving away personal information. Obviously, there are a lot more use cases as well besides just data analysis. You could also just verify user logins, and underneath you could build a layer where you could store data. Was that useful for you?
Yeah, David, there is one more question. A student sent it to me. I just shared there. Maybe you can see regarding the external certification.
Yes. What is the aim of the Fala project? So the Fala project is making or providing a fundament for confidential cloud computing, basically what I talked about, and overcoming the obstacles of legacy blockchain technologies that are too transparent, so that you can build an additional layer and also make it scalable, which means that you don't have duplicate transactions as in the Ethereum network, for instance, which makes actually or allows you or opens you the doors for new cloud applications and use cases. And obviously this project is still in the early stages, but it has already been successfully used in pretty interesting use cases.
So there is one question regarding external certifications like AWS. So you can.
Yeah. So concerning external certifications, as mentioned earlier, AWS Cloud Practitioner is the first one I would do, and then once you have that, you should focus yourself and see where you see yourself, because then they have the cloud security certifications in that. If you're more a security guy and are more interested into networks in the cloud environment, then do that after that. More industrial experience in the industry. But there are also some for engineers where you also can learn agile methodologies and also DevOps certifications. So after you've done the cloud practitioner, you should get a fundamental understanding also with Sukhpal's course, and then decide what direction you want to go into, because these are specializations. And once you have reached these specializations, you will see that your salary will actually tremendously increase. Because you will be in high demand and able to provide more value. But don't just go for certifications, get work experience as well on top of that. That's very important. So these certifications should be seen as a starting point to somewhere, as a fundament.
Yeah, that's good. Thank you. So any student has any more question? So one more thing. So how a student can contact you, David? So would you like to provide some email, yes, or something? So
email or LinkedIn, anything is fine for me. And if they don't want to necessarily contact me, but my company, they can also go onto our website. So all three are fine. Yeah, I mean, you're very welcome to share my email and my LinkedIn.
That's fine. Yeah, I will share with you.
Yeah.
So one more question.
So I just got an additional question from Rahul. And it was, what do you think about the AWS Solutions Architect certification? So I don't know the details of this certification, but I believe, correct me if I'm wrong, this is one of the expert certifications where you become a solutions architect, which is more or less a certification where you allow we're in a team on a higher level and architect the solutions in a cloud environment. So if that is something of your interest to build things and be one of the first people to work on concepts, this is one specialization you can go into. But I mean, they're not that cheap, the specializations. So that's why think about that in beforehand. And if you get or have the chance to actually do that in industry beforehand, try to do that beforehand before you do one of these certifications, if you have to pay it yourself. It's also always best to find an employer that pays for that.
Yeah, that's very interesting. So one question generally students are asking, how this academic life and industry lives are different. So suddenly they have to change from academic life to industry life, how it will make change for them and how it will be like challenging for them. So maybe you can comment on this.
Yeah, so if you've done internships in the past, you will know core differences. So I would say the core differences I experience from academic life is academia gives you the theory and a fundament which you yourself have to build on. And also Queen Mary is a university that constantly triggers that you yourself are there to achieve more. You're solely responsible to learn more by yourself. No one else in the working environment will come to you and say, well, you haven't achieved this. You need to be very enthusiastic and take things on by yourself. And no one will throw information at you when at all times when it is required. You need to go out there and find them, and you will see that there will be gaps in certain projects, and then it will be your responsibility, if you're enthusiastic to progress along your career, to fill these by yourself, by teaching yourself even more. Even if you're in some courses, you will hit your limits. I mean, Supal made it actually very, very realistic. He doesn't teach you everything because that's not possible. And I remember even in your course, Supal, there were some topics where I had no prior experience or knowledge before that. And like in the working environment, then you will be expected yourself to fill these gaps, either through Googling or taking additional courses if you're unfamiliar with specific topics. And nowadays the internet is there. You can get a lot of information about this, but also courses from YouTube on how to learn or how to use libraries within the Linux environment. So that's why it's important to constantly develop yourself. And the environment is moving also extremely fast, a bit faster than in academia, I would say, in terms of tools, what tech stack is being used.
Yeah, that's very useful answer. So any student, if you have any question, please feel free to ask. Maybe you can turn on your camera or turn on your mic, Rahul.
Are there training contracts available through the firm? So would you mind elaborating that a bit more so I can understand the question a bit better and address your needs here, Raul? What do you mean by training contracts?
So I would like to know more about you have done some work in this Airbus and MBDA missile systems. So as a researcher, so basically what you have done here?
What I've done at Airbus Defense and Space?
Yeah.
Yeah, we had a case where we had to transfer data from A to B in a secure method, and we worked together with, or we had the use case from the German Air Force there on how to leverage this. So I was given this problem, and then I went into my MSc project with Steve together back then, and I tried to solve this problem by doing even more research and then developing a prototype that provides a proof of concept. And it was pretty tough because the defense environment is significantly different than the, I would say, civilian industry, because they have isolated environments and they also have usually an older tech stack, because they don't constantly update it, because they don't know about the vulnerabilities by introducing new technology into there. And it's critical environment. So this is the information I'm allowed to share about that.
So cybersecurity is your passion.
Yes, it is my passion, and I was able to combine it with a cloud exchange project.
A profession. Yeah, that's really good.
Cloud and cybersecurity, because the cloud will always be relevant.
Yeah.
You also need to understand the vulnerabilities there, and there was just a recent vulnerability that we fixed as well. It was on an Ubuntu level, and that was pretty interesting on how to secure cloud servers in that case, because what happens with data breaches if you don't do that. So that's vital.
Yeah. Hi, David. Hi. This is Rahul. I just wanted to find out a bit more whether any internship opportunities or training contracts would be available through MHIT and service.
Sure. So if you want to go ahead and send us your CV or contact us directly via MHIT, okay. With a like a rationale what you would be interested into doing, we would probably be able to find a project for you starting, I would say, in late summer, if that still fits your schedule.
Okay, that's perfect. Thank you very much.
You're welcome.
So any student has any question anymore? So you have done some work in the Silicon Valley, so taking parts in the various startups. So still you're working on some of the projects, or so now you're not working with them?
So that was back then with my bachelor, or during my bachelor's degree. That was not that technically focused, because I did like a commerce degree at Queen Mary. That was for a marketing agency, PR marketing agency back then. No, yeah. So I don't work there anymore. No.
All right. But it's very interesting. Like you have a vast experience and you have tried many things in your life for this cybersecurity and all these things. Yeah.
Yeah. Also, trying to build startups and keeping companies grow. Most of them in the technology field, or I would say pretty much all of them, and then also finding the need for cybersecurity nearly everywhere.
So that's why I shared your MSc so coursework. So whatever you have done for cloud computing with the students, because it's very well explained, and you have also created the GUI so they can understand it easily.
Thank you. Yeah, I mean, that is also important. Also, an advice I can give out to you. Employers really value documentation. And that's why we also valued the documentation by making it as accurate and as easily understandable as possible, because in the industry, where once you work somewhere, you will have technical and non-technical users. And it should suit for both audiences. If the technical ones go in, they will see this, and if they want to go deeper, they go into the deeper parts. But the non-technical users will stop at a certain moment, but you still want to document them, else you will lose out on that. When you either want to sell your product there, or even within the workspace, this will also show you as a team leader and that you're able to collaborate with different people within a company.
Yeah, documentation should be for the general audience.
Yes.
Yeah.
That is very important.
So, any more questions you can ask if you have, or otherwise you can connect David with the email ID, and I also shared the LinkedIn, so you can connect him. So any student has any more questions? So because we have still 5 minutes left. So any kind of message you want to give to the students, David?
Yeah, keep on studying well. I know that the market gets more and more competitive, but go for your passion, because if you're passionate about something, there's so many topics you can go for, then you will excel, and then you will be able to overcome the competition, I would say, if you go for whatever you're passionate about. I mean, there's so much stuff. If it's not necessarily cloud, it can also be something else, just data analysis, but still in a cloud data analytics to do service to take care of. That's one advice I could give I would give the students. Do whatever you're passionate about and build on top of that. Yeah,
that's really interesting. So I don't think so any student has any more questions. So maybe students can connect with you through the LinkedIn, or they can contact you through the email later. So that's it. Thank you very much for your time, and thank you very much for your nice, wonderful talk. I really appreciate for your time.
Thank you as well, and then let's connect later as well, if that's fine. And if you have any additional questions for you students as well, feel free to reach out to me, and Supal shared the contact details. Yeah. Thank you.
Yeah.
Have a nice day then.
Same to you. Thank you very much. Thanks everyone.